Hello guys, with Team 15, formed by Ricardo, Charlestin, Xavier, Bercy, and myself, Yetsey, Suero. We're going to be talking about welding, its methodologies, and future developments. I'll be talking about a little bit the background of welding. Before I start, I want to first define what welding is. Well, it is informally defined as a process by which materials of the same fundamental type are caused to be joined together to form chemical bonds with or without the addition of heat or pressure. But more formally, the American Welding Society defines it as a joining process producing coalescence of materials by heating them to a welding temperature with or without application of pressure or by the application of pressure alone, and with or without the filler material. There are four main points implied in the definition of welding. First, it applies also to plastics, glasses, and ceramics, not only to metals. Secondly, it is the result of the combined action of heat and pressure. Also, it may or may not require the use of a filler material. And finally, it is constrained by the materials being joined. The origins of welding dates back to the Bronze and Iron Ages, where nuggets of gold or silver were hammered into rods and then used to form continuous rings. It was so in 310, the iron pillar of Delhi, right here to the right, was also a structure 25 feet high and weighing about 6 tons. Was also forge welded by blacksmiths using iron billets. In the Middle Ages, many iron items were welded by blacksmiths by using heated metal, by pounding heated metal until bonding occurred. In the 1540, the first metallurgical book was written by an Italian called Vanation, describing the forging operation. And however, until the 18th century, only simple methods of flow and forge welding and brazing were used. The first half of the 19th century paved the way for the future development of welding. First, in the 1800s, a Cornish chemist called Sir Humphrey Davy developed the electrical arc, which was composed of two carbon electrodes powered by a battery. In 1836, the Sabri was discovered by Edmund Davy, although it wasn't practical until about 1900, where a suitable torch was invented. In 1885, the Russian Nikolai Benoders and the Polish Stanislaw Osuski invented the carbon arc welding, which also uses carbon electrodes powered by a battery. And also, the American engineer Eddie Thompson invented the resistant welding in 1885. In 1890, Charles Coffin, an American engineer, invented metal electrodes, winning the first U.S. patent. On the 20th century, major advances were made in welding technology. First, from 1905 to 1930, oxyacetylene welding became the universal method of welding until it was gradually replaced by electric arc and resistant welding. After World War I, the use of welding processes sprang up since they became indispensable in many areas such as in ship and aircraft construction. In the 1920s, automatic welding was invented, in which electrode wire was continuously fed. The auto industry started to use automatic welding, and the alternating current welding machines became very popular. In the 1930s, the popular method of stud welding was developed, and it was soon followed by another very popular method at that time, and still today, called submerged arc welding, which was introduced by the National Tube Company. Some of the modern technologies include friction stir welding and magnetic pulse welding. The first one uses rotational speed and pressure to provide friction heat, and it encounters many applications in the automobile and aerospace industry. The second one, magnetic pulse welding, is a powerful welding method which uses electromagnetic forces to create a solid state cold weld at room temperature without the need of heat, filling material or gases.
Hi, my name is Ricardo Charlestin. I'll go ahead and proceed with the common welding methods. Over the years, we have heard of many different types of methods, but based on many industries and high-end users' preference, just a few of them remain common. As common welding methods, we have the GMAW or gas metal arc welding, the GTA or tungsten inner gas, the SMAW or arc welding, gas or oxy acetylene welding. The GMAW of gas metal arc welding is also called MIG welding. It is the most easiest to operate, easy to master. It is suitable for fusing mild steel, stainless, and aluminum. It is so far the fastest growing method within the industry. It is known for 70% of weld material within the United States, and also possesses the ability to be wire fed for robotic purposes. GTA or tungsten inner gas, known as TIG welding, is good for high quality work. The equipment are rated from 170 to 300 amps, and unlike MIG, they utilize lasers, which is the latest in welding technology. They use non-consumable electrodes, and they are the best choice of working with non-ferrous metals. Shear metal arc welding, or SMAW, is also called some places as the stick welding. It is the oldest method, not easy to master, not easy to operate. They use for manufacturing, construction, and repairs. They are pretty cheap. They provide a lot of spark, smokes, and residue, which require a lot of cleanup after the work is done. Gas or oxy-acetylene welding and cutting, which is one type of method that can be used for welding and cutting, but it is preferably used for cutting. They mostly use that type of welding for maintenance work and gas metal cutting. And it is also common for brazing softer metals like copper and bronze.
Xavier Bercy, and I'm doing the future development. So I'm going to be talking about the gas metal arc welding. It will continue to accelerate since it is being substituted for the shear metal arc, the gas welding, the brazing, and the resistance welding. And we have the gas tungsten arc welding. It will grow faster than the other metals. And the two reasons are it adapt to automation and has a very high quality. And we have the flux core arc welding. The flux core arc welding from a was from a lower base. Now it is growing modestly. We have the plasma arc welding. The plasma arc welding will go faster than the gas tungsten as soon as the capabilities are better known. Health and safety. It always required to wear a helmet when doing welding so the sparks don't burn you. You need a helmet to protect the ear and face, the clothing to protect your skin so the sparks don't fall on your skin. You need the goggle to protect your eyes from the spark as well. And that was our presentation, and thank you.